this video we are going to be looking at sec inverse of x. Now if we are given y to be equal to sec inverse of x and you are to find dy dx, it means sec y is equal to x. Now let's differentiate this. Let me call this one implicitly. If you differentiate this implicitly, it means we are going to have tan y sec y. Then this dy dx equal to 1. Making dy dx the subject of the formula, we are going to have 1 divided by tan y sec y, and let's call this equation 2. Now from our trigonometry identity, we have that tan square y is equal to sec square y minus 1. Now making tan y the subject of the formula, we are going to have square root of sec square y minus 1, and let's call this star. Now substituting star into 2, we are going to have dy dx to be equal to 1 all over. Instead of putting tan y, now we are going to have sec square y, square root of sec square y minus 1. Now this we are going to have sec y multiplying square root of sec square y minus 1. Let's call this equation 3. Now from equation 1, we have sec y to be equal to x. It means sec square y will be equal to x squared. Therefore this means dy dx will now be equal to 1 all over. Instead of having sec y here, we are going to have x. Then this square root, now instead of having sec square y, we are now going to have x square here minus 1, and this is your dy dx for sec inverse of x. This is your dy dx for sec inverse of x. You could also write it as d dx of sec inverse of x, which is equal to 1 all over x square root of x squared minus 1. Thank you. Please like this video, subscribe to this YouTube channel, and don't forget to hit the notification bell so you could be notified each time we upload a video. Thank you.